So welcome to today's lecture. Today we'll discuss about two very important multi-criteria decision-making methods, which are very basic, very easy to apply, but very useful to implement also. In case of multi-criteria decision-making methods, these two methods are the initial methods which were proposed in the initial years when the MCDM concept is gaining its popularity. So first I will discuss about weighted sum method, and then I will move to weighted product method. So what is weighted sum method? Now Fishburne in the year of 1967 in the Operation Research Society of America, it proposed a new method known as weighted sum method. This was 1967, so you can understand how old the MCDM methods are. So in the year of 1967, he proposed about this method, and it was a very basic method. So where it states that the importance of an alternative for a given problem can be found out with the help of decision factors or decision criteria by multiplying the weightage of importance assigned to the decision criteria with the value of the alternative and summing all of them to find the WSM score of the alternatives. So this method was modified later on, and I will discuss about the latest modified WSM method. So let us begin with an example. Okay. So our example is that we have to buy a car, and the criteria of our purchase is cost and speed. The alternatives available is Mercedes, Jaguar and Toyota. Now we will use the aggregation method as not A and B but weighted sum method. So let us take the example. Okay, so this is the example. Now you see here what will happen is the values of the criteria, both of the criteria, cost and speed, for Mercedes, Jaguar and Toyota is already given. Now your first step will be, step one will be to normalize this value, because you have to ultimately add both of these values. Now you see the unit of cost and unit of speed is different. Unit of cost is in currency, speed is kilometer per hour or miles per hour. So you cannot apply numerical operators like addition, multiplication and etc. on a value which is of different units. So that is why it is always better to normalize and cancel out the respective units. So what happens is, in case of cost and speed, what we have done is, if this is the value of cost, if this is the value of cost for Maruti, value of cost of Jaguar and value of Toyota, value of cost for Toyota, then what we have done is we have sum, that means so it is coming up to 1, right? We have add all these values, and then we have divided this summation to each of the individual values. That means the value of Mercedes is 0.5, we have divided 1 and found out that the normalized value is 0.5. Actually what happened is, this 0.5 is in rupees, this is also is in rupees, correct? Now when you divide two values of same unit, the unit gets cancelled out. So this 0.5 is a unitless magnitude of cost for Maruti. Similarly, we have divided 1 with 0.3, 0.3 by 1, it is coming as 0.3. So Jaguar normalized. Cost of Toyota was normalized the same way. And again, in case of speed, we have added these values and then divide the summation from each of the individual values. So the summation of these three is again 1, and when you divide 1 from each of these individual values, it remains as it is. That means 0.2 by 1 for it is Mercedes, 0.5 by 1 for Jaguar, and 0.3 by 1 by 0.3 by 1 for Toyota. Correct? Now we will apply the aggregator. So in case of WSM, weighted sum method, the step is like this. You multiply this value, that is the normalized value of cost, with the weightage of cost. Now this weightage will be already, weightage of the criteria will be already given in your numericals, and this weightage depends upon the individual decision maker. That means for me, cost is important, speed is less important if I compare both of them. That is why I have assigned more weightage to cost than speed. But for you, it may be different. Okay. So with change in decision maker, this weightage will also change. But what you have to do in WSM is you have to multiply the value of cost for percentage with the weightage of cost criteria. That means you will multiply 0.667, the weightage of the criteria cost, with 0.5, the value of cost for Mercedes. Then you will add the weightage of, you will add the product of weightage of speed with the value of speed for Mercedes. That means in case of weightage of speed, it is 0.3 multiplied by 0.2. Now the resultant will give you the WSM score as it has been given here. Now in the same manner, you will multiply the weightage of cost with the value of cost for Jaguar. Then add it with the product of the weightage of speed with the value of speed for Jaguar. Then similarly for Toyota. Now you find these WSM scores. Then you rank it as per magnitude. Move the magnitude, higher will be the rank. That is why the highest magnitude among all these three alternatives will get the best rank, that is 1. Followed by the next higher magnitude, then last is 1. So in case of purchasing a car for B, as I am the decision maker here, Mercedes-Benz will be the best choice. Okay. So for you, if you change the weightage, then the decision may be different. Now, one thing you must remember that here there is an anomaly or error in it. You see, in case of cost, more the cost, less preferred will be the alternative. Actually, we all look for the lower cost product. If for me, if cost is more important, then I will see among all these three, which one will have the least price. Now, remember here 0.5 is assigned to the cost which is lowest here, and in this way this anomaly was overlapped. The best thing is to do is that if if you use order, suppose the same problem, if you take cost and speed and order them as per their rank of preference, correct? Then based on these values, the best order will be assigned to this Toyota because it has the minimum number. So these will be your 1, followed by these 2, then these 3, because it has the highest value, and when cost is highest, that alternative will be least favored. After assigning rank, in case of speed, more the speed, higher will be the preference. So that is why if you assign rank to the value of the speed, then this one will have the highest rank because it has the highest value for speed, followed by this one, then this one. Now, to convert this order, value of order, into its corresponding magnitude, which represents the significance of the alternatives, what you have to do is, you have to use the inverse rank formula. Inverse rank formula states that if your order is n, you will divide that order with n plus 1. And then you will deduct this value from 1. So you see, this m is the order, n is the total number of alternatives plus 1. So what will happen is, if you deduct this entire value from 1, the least rank value will have the highest magnitude. How? Take the example of Mercedes for cost. Take the example of Toyota for cost. So here rank is 1, m is equals to 1. So 1 I will keep. N is 3 number of alternative is there. So n will be 3 plus 1, 4. So 1 minus 1 by 4. So it will come around 1 minus 0.25, which is coming 0.75. You see, this is the least rank, it gets the highest value. That is what we want. So for the second best value, that is for Jaguar, you do the same thing. It is coming as 1 minus 2 by 4. So it is half, so it is coming 0.5. And the least rank value, least ordered value, that is Mercedes, so it will come around 3 by 4, 1 minus. So it is coming around, see, it is coming around 0.25. So it is the least value. So yes. So what has happened? You can easily understood that the highest rank is getting the least value. The least rank is getting the least value. But if I would have not applied this inverse rank formula into it, magnitudically the implementation or implication will be different, because if I use only rank as the magnitude, which represents the importance of the alternative, then you see 1, 2, 3. Then Toyota is the least important because 1 is lowest compared to 3 and 2. Similarly, Jaguar will be the second least, and here Mercedes will be the most important because it has the highest magnitude. So the entire information that we want to represent get reversed. So that is why it is better when you are using order or rank in place of values of the alternative for the criteria, you always inverse the rank into its corresponding magnitude to coherently represent your information. Now here you note that this entire inverse rank has been implemented, and then only it has been shown here. So that is why, as Mercedes has the lowest cost, it has been assigned the value of 0.5, followed by Jaguar, and Toyota has the highest cost. That is why it has been assigned the value of 0.2. So these are 0.5, 0.3, 0.2 is given after inverse ranking the alternatives, right? But if you consider them as magnitude only, then the decision will change. Decision will just be opposite compared to what we want to represent. And as usual, as this is after inverse ranking, so that is why Mercedes was selected as the best alternative, because it has the highest value for cost after inverse ranking, and I have given the highest weightage to cost compared to speed. That is why this has been my most preferred or most dominant alternative among these three. So this is overall what weighted sum method is. First, you will get the data. That means you will have criteria. You will have the weightage of the criteria representing its significance with respect to the decision maker. And then what you will do is you will have also the values of the criteria for your given alternatives. The first step will be to assign order or rank with respect to your preference. That is why the least cost alternative was given the best rank, and worst cost or the highest cost alternative was given the worst rank. And after assigning order or rank to those alternatives based on the value and your preference, what you have done is you will use the inverse ranking formula 1 minus m by n plus 1, where n is the order assigned to the alternative with respect to its preference and value, divided by n plus 1. N is your total number of alternatives available here. And after implementing the inverse ranking formula, you will see the rank is coherently converted to its magnitude, and which coherently represent our preference for that alternative. And after then you multiply the multiply the value with the weightage of the respective criteria and add it with the product of the value of the other criteria and weightage of the other criteria, and you add them to find the WSM score. Then, as with respect to WSM score, you again assign order to the alternative, where the alternative with the highest WSM score gets the best rank of importance, and the alternative with the lowest WSM score gets the worst rank of importance. So it was explained with this example. So this ends the WSM method. So our next method will be weighted product method. So in case of weighted product method, take the same example. We want to buy a car, and we will consider the cost and speed of the alternatives to make our decision. And if I see that we have the alternatives Mercedes, Jaguar and Toyota, right? So all the steps that we have followed in case of weighted sum method up to the aggregation step is same. That is, you will rank as per the value and your preference. Then you will apply inverse ranking. Then you you apply the inverse ranking, and then you stop. Now, another thing you must notice: if you do not assign the order or rank to your alternatives based on your value and preference, then you have to normalize. But if you have applied your order as per the value and preference of the alternatives, then there is no need to normalize in that step. You can straight away use those values. Okay. Now, because why you do not require to normalize is rank do not have any units, so these are already units. But if you want to apply the aggregation onto the values of the alternative, then if you consider only values, those values are units. So you have to normalize to cancel out the units. So let us come back to the weighted product method. So here also in the step 1, you assign order or rank to your alternatives based on the values of the alternatives and your preference. Your preference means if it is cost, which is just inverse to the objective of your decision, you always take the least cost alternative, because we always look for the lowest cost alternative at the time of purchasing something. So that is why lesser the value, higher will be the preference. So that is why when you are assigning order to such type of criteria, to the values of such type of criteria, then you must implement your preference, not just bluntly assign the order as per magnitude. For speed is coherent to the your decision making. More the speed, you will prefer the alternative. So that is why no problem for speed, but for cost, you have to consider your preference. Then, as you know, in the second step, you will apply the inverse rank formula, which is 1 minus m by n plus 1, where m is the order of the alternative, divided by n is the total number of alternatives, plus 1. So after doing that, now for weighted product method, the way we apply the aggregation method is different compared to that of weighted sum method. In case of weighted sum method, we multiply the value of each alternatives with its respective weightage of the criteria, and we add the values to the product of the weightage of other criteria multiplied by the respective values of the other criteria. And then as per the WSM score, we again order the alternatives and we get our decision. But in case of weighted product method, what happens is, let us take the same thing. Okay. This 0.5, 0.3, 0.2 is after step 2. Okay, so don't think that this is the exact values of the alternatives. Now, here also I have given higher weightage to cost compared to the weightage given assigned to speed. Now, let us see how the aggregation method, we say it as aggregation method because it is aggregating the preference of the decision maker with respect to all the criteria based on the values of the alternatives. So, in case of aggregation method, for WSM, our aim was to find the WSM score. For WPM, our aim is to find the WM score. So how we do it? Okay. So what we'll do is, we'll take, in case of cost, we will take the value of cost and divide it by the value of Jaguar. with the second alternative. Okay, and we'll power it with respect to the weightage of the criteria. So the weightage of the criteria is 0.67. So in power, I have given 0.667. And in this operator, I have divided the value of cost for Mercedes by the value of cost for Jaguar. So 0.553 to the power 0.667. Then I will add this to the same for speed for the same alternatives. That means for speed, it was 0.2 by 0.3, and then at power, the weightage of the speed. This is the weightage of the speed. Value of speed for Mercedes is 0.2, that is placed in the numerator, and the value of Jaguar, which is the next alternative, the value of that is placed in the denominator. And we'll have this equation. Let it be the WPM score for Mercedes. In similar manner, what we'll do is we'll find the WPM score of Jaguar. How? Here, WPM score of Jaguar can be found out by 0.3. The value of Jaguar for cost will be in the numerator. Value of Toyota will be in the denominator. And we power it by the weightage of the criteria, 0.667. And you add it to the same for speed, that is the other criteria. Here it is 0.3 by 0.5 multiplied to the power 0.33. Okay. And that will give you the WPM score for Jaguar. And then lastly for Toyota, to find the WPM score for Toyota, what you do? The value of Toyota is 0.2. Now already we have compared Jaguar and Toyota, but we have not compared Mercedes and Toyota. That is why 0.2, the alternative which I am comparing, will be placed in the numerator, and then 0.5, the value for Mercedes, that means the alternative with which I am comparing, will be in the denominator, to the power 0.667. Similarly, for speed, value of Toyota for speed is 0.5 divided by the value of speed for Mercedes, that is the alternative with which I am comparing it, and then to the power 0.2. You note that after point I have used 3 digits. After point I have used 3 digits. So maintain this uniformity for all other cases also. That means for here also you use, instead of 0.5, use 0.50, use 0.30, 200. Correct? So this rounding on after decimal, it must be uniform for criteria as well as for trivial. Although this is not essential, but it looks good to be uniform. Now, after this, what we do is we compare the WPM score of this, what I say is this Mercedes, Jaguar, and as well as Toyota. The score which is largest or highest among all these 3 alternatives will be your selection. That means that will be your selected alternative, most favored alternative, or the dominant alternative among all the three alternatives you have used. So I think these two methods are pretty easy. In case of weighted product method, what we are doing is we are using a ratio which is powered by the weightage of the criteria. We are using the ratio of the values of the criteria for the two alternatives at a time, and we are powering it by the weightage of the same criteria, and then we are adding the same thing with the for the other criteria to find the WPM score of the alternatives. After finding the WPM score, what we are doing is we are comparing the WPM score of all the alternatives, and the alternative which has the highest WPM score is selected as the best alternative or the dominant alternative among all of these three. So these are a very simple example with which I have tried to explain these three very easy methods, weighted sum method and weighted product method. First two steps for both the cases is same. If you apply rank or if you apply order to the given values of the alternatives, then you apply the order, assign the order based on the values as well as the preference of your decision, and then apply the inverse rank formula 1 minus n by n plus 1. And then for WSM method, you multiply this value with the weightage of the respective criteria and add with the same for the other criteria to find the WSM score. And for WPM, you find the ratio with any two alternatives and you power it by the weightage of the criteria, and then you add the same for the other criteria and you find the WPM score of the criteria of the alternative, which is placed in the numerator of the ratio, and then you compare the WPM score of all the alternatives, and the alternative which has the highest WPM score is the selected alternative. Now for the simple method, I have to remind that you must be very careful about the preference. As for example, cost is not coherent with your decision because we always prefer for lowest cost. So when that is the case, your preference becomes extremely important. But it is not so important for the criteria speed, as more the magnitude, higher will be the preference naturally. And another thing is there might be some criteria which cannot be expressed in numerical values. We express it by qualitative values, like very good, like very good, very bad, bad. Say for example, if I add a criteria known as style of the car, then you cannot represent it or express it with the help of any numerical value. We have to use some qualitative value like very good style, bad style, like this. So in that case also, it is better to assign orders because the style with better quality, that is, will have the best order, best rank, and the style with worst quality will have the worst order or worst rank. Suppose if I introduce style here, in case of this problem, if I use it, then what will happen? For Maruti, I will say style is very good. For Jaguar, it will be good. For Toyota, it will be not so neither good neither bad. These are just randomly I am saying. So here, very good is indicating that this must be your most preferred alternative. So you assign the best rank to that, best order to that, followed by good, and then neither good, neither bad. So the qualitative rating that you have assigned will show that how preferred that alternative is to the decision making. And accordingly, you have to assign order or rank to that alternative. Right? So after applying rank, assigning rank, you do the same thing as you have done for the other criteria. That is, apply inverse rank formula. And after then, the aggregation method for WSM, just multiply with the weightage of the criteria and add to find the WSM score. And for WPM, you find the ratio, power it by the weightage of the criteria, add it with the same for the other criteria to find the WPM score. Compare the WPM score or compare the WSM score, find the alternative which has the highest score, and that will indicate that that alternative is the most dominant alternative, most preferred alternative, and you must select that alternative. So with this, I end this presentation and my explanation about WSM and WPM.